Alright, this is the question about trigonometry. That means the sine formula and cosine formula questions. So in order to solve part A, it's better to have a diagram on right hand side because you just mentioned that ABCD is a trapezium where DAD is parallel to BC, but it doesn't show any details about this. Alright, so in order to find this correctly, we have to draw the diagram here. So in order to find CD, because this is a little bit difficult one, all right, so we need to draw a line that from B to what's AD, which is still parallel. Maybe we call this F. BF is parallel CD, all right? And then for this, we can conclude that B, C, D, F is a parallelogram. Okay, so if this is a parallelogram, if angle ADC is 70, then this one, that means angle AFB is also 70. All right. And also based on the properties of parallelogram, actually CD is the same as BF. So if we can find BF, then we can find CD. All right. So based on this fact, all right. So in order to present properly, okay. So it's better to let F be the point on AD such that BF such that BF is parallel CD. Okay, so of course, as we have mentioned that since BCDF is a parallelogram, we can conclude that CD is equals to BF, and also angle AFB is equals to angle ADC equals to 70. Okay, we have these two facts. All right, so for this, we have 70, we have 45. Here is the corresponding pair of angle and sine, and also 50 and BF, they also cause a pair of corresponding angle and sine. As a result, we can use the sine formula to help us to solve this. All right, so for the formula, BF, use the wrong pen, BF over sine 50 is equals to AB, that means 45, over sine 70. All right, so after solving this, we know that BF actually is equals to 45 sine 50 over sine 70, so it becomes 36.68433611. All right, since CD is equal to BF, so as a result, CD is equal to BF equals to 36.684 something, approximately 36.7. Okay, so this is answer for part A. Okay, for B1, one more condition that we have in this diagram is BC is equal to 40, so this is 40. All right, and then we need to put another letter E, which such that BE is perpendicular to AD. That means this is 90 degree here. Okay, so we are going to find CAD. Where is CAD? CAD is approximately here. Of course, for this one, we don't have any information except we have 40 here. All right, but we have no idea about the information on triangle CAD, so as to find the angle CAD. So for this question, because we use the sine formula in part A, so definitely we have to use the cosine formula in part B, okay, including B1. So for the cosine formula, in order to find angle, we can come up with this one, equals to a squared plus b squared minus c squared to ab. Alright, cosine formula. So cosine formula for finding angle, we need three sizes. Okay, so one of them, CD, is provided. So we are going to find AC and AD respectively. Okay, so how we can find AC and AD? We need to know some more information first. Since we know that BE is perpendicular to AD, so we can have a conclusion that BED 90 degree, also AEB is also 90 degree. Alright, and then moreover, from the sentence here, the metal shape is floated along BE such that A is perpendicular to the plane BCDE. That means this is also 90 degree. And one extra thing maybe you don't know, if we fold like this, alright, angle ABC is also 90. If you don't understand, you can find a piece of paper and then cut it into the trapezium and then throw it this way. You can see that ABC is really 90 degree. Okay, so if we have very two important 90 degree here, so can you guess how can we find AC and AD? You're correct. Okay, well, actually we are going to use Pythagoras theorem to find AC and AD respectively. Okay, so first of all, we talk about AC first, because AC is a little bit easy for us to do so. Alright, so for AC, since AB we know that is 45, okay, oh sorry, wrong pen, 45, and then BC is 40, so AC is equals to AB squared plus BC squared. Alright, so that means 45 squared plus 40 squared. So it becomes 60.20797,289. Okay, easy for finding AC. AC already fine. Okay, so next, AD, a little bit complicated. Okay, because in order to find AD, we need to find the value of AE and also ED. So find AE first, because AE is easy. We can see that AE is equals to AB cosine 50, right? Because AB is a right angle triangle. So it becomes 28.92544,244. And then how do we find ADD? If we draw a vertical line here, okay, maybe we call it G, no, not G, maybe we call it H, okay? So actually ED is equal to DH plus EH, and EH obviously is 40, right? Because corresponding size of rectangle. So for ED actually equals to EH plus HD. So EH is 40, and then HD also use the cosine ratio, okay? Because CD we have already calculated before. It should be equals to 36.7. Okay, so become AD cosine 70. So the final answer of ED, okay, is equals to 52.54678,189. Okay, so in order to find AD, Pythagoras again, AE squared plus ED squared. Okay, so we can obtain 59.98204,321. Alright, so if three sizes already obtained, okay, so cosine angle CAD will be equals to AD square plus AC square minus CD square over 2 bracket AD AC. Alright, so final answer for angle CAD will become 35.542078. Okay, approximately equal to 35.5 degree. Okay, this is the answer of B1. Okay, finally for B2, does the angle between the plane ACD and the plane BCD exceed 30? So we need to locate the angle of these two planes first. The angle between two planes actually is equal to the angle between two perpendicular lines towards the line of intersection of these two planes. So for the perpendicular line, we can draw from A here. The line of intersection should be CD. And then for the plane BCDE, since AE is perpendicular to the plane, so we can starting from here to draw a perpendicular line, and then the angle theta is the angle between the plane ACD and BCDE. Alright, so if we are going, because we know about AE, alright, AE actually we know about the size, right? AE is equals to 28.925. We calculate in part B1. Alright, so for this case, we need to find, it's possible for us to find the perpendicular line on the plane ACD. We let this become G. That means we need to go into find AG. So how do we find AG? If you remember the area of triangle, there are two ways or three ways, okay, to calculate the area of triangle. One very basic skill is base times height equal to 2, right? So for this, consider the area of triangle ACD. First method, AG times CD over 2. And then the other method, since we obtain the value CAD is 35.5 degree, right? So we can also make good use the formula 1/2 for 2 sides times size angle CAD to obtain the area of triangle ACD. So based on these two formula, when we combine them to get the form of equation, then we are easily get the size of AG, okay? Because CD we knew already, right? CD is equals to 36.7, okay? And then ACAD we already calculated before, okay? So for AG, and then CD is 36.7 over 2 equals to AC is equals to 60.207 something, and then AD is 59.9 something, and then sine 35.5 degree. So after solving it, AG will become 57.22631.076. Remember, for using the value here, should use the exact value, not the estimated value. Otherwise, the answer may not be correct. And finally, we are going to find theta, right? So for sine theta is equals to AE over AG. So we can easily find that the theta is equal to 30.36169732 degree, which is greater than 30. So the claim is correct. Okay, so we can say yes.